is we talked about the Nordic specification earlier, but now we're going to talk about the technical guidelines. Because we talked about the process earlier, now we're going to talk about how to do the analysis and what kind of tools could I, as a consultant, have to do it. Because the building authorities, like in Sweden, they give us some magic numbers sometimes, some regulations to fulfill, but they never talk about how I can do it. And the last 3 years, my company, we started to do internal guidelines to ensure that our quality was good enough. So we knew that the answers we were given to our customers were right. And to do this, we started to work with guidance, mostly on different technical issues like fire, smoke, evacuation, but also on the way to design buildings, what to ask the customer, what to ask the architect, to have as a guiding reference document when you are a junior consultant, but also for me that I've been working for 7 years, but I know that I haven't missed anything. And 1.5 years ago we choose to publish 2 of our guidelines because we think, well, it's fine to spread the word. And the Danes did something like this in the 2009, 2010, just about CFD modeling with FDS. But we have works in a wider concept with different kind of questions. So that's why we're working with our technical guidelines. And I will give you a short information on our thoughts about this work and why we have done it and what is the value of doing it and how could you do it in the future. And I put out some guidance here that you could take if you want. If you want to have it in electronic way as well, I've got some USB memory sticks with guidance on. And this summer we're gonna release 2 new ones, but I will give more information about that. And of course, if you have any questions, just ask them. And this presentation is in Swedish, so it's a bit more common for you maybe to understand, but it's going to be fine. But the first question is, why technical guidelines? Why don't just rely on the building authority, the society to tell me what is the right way to do things? Well, the society doesn't have the resources to do it, and it's the industry that has to take their responsibility to know how to deal with kind of things. And I think it's that's the first question that you have to ask yourself, because the guidance that the building regulations give me isn't enough. Because of that I need to have my own guidance to know how to do it. But it's not doesn't mean that it's my guidance or my company guidance, but the fire safety engineering society guidance. Because even if we have different kind of building regulation, it's still the same kind of physics that the phenomena is about, like fire dynamics or evacuation, to now walking speed and things like that. So it's a universal part of it. But somewhere we have to start to work with it. And what are they good for? I will give you the information about that. Well, as I said before, I think one of the most important thing when you work with fire safety engineering is to understand what is the problem. Is it even a problem? And when there is a problem, how should I manage to solve this problem? But like the way it is in Sweden at the moment. If you define a problem and you know you have this program, for example, advanced safety program, then you always go to that program and try to solve your problem you have. Instead of asking you, how big is my problem? Are there different ways to solve this problem? And because of this, you're gonna need some kind of guidance to know, okay, the problem exists, but the level, the complexity of the problem is this much. Well, then I could use like a 2000 model instead of this safety model. And the smoke, and the analyzing of the fire smoke prevention. And it's the level of the how I do my analysis should be defined by the complexity of my problem. It's the first question you always have to ask yourself. And when you have asked yourself that and identified that you have a problem, then you have to know how to do the process. Like I told you before, I really like the way of working with processes to know that I'm doing it in a right order and I don't miss any projects. And I also will increase my transparency. It's going to be easier to understand what I have done, and it's going to be easier for the auditing part to understand what has been done. Is it in a good way or bad way, or is it just colors, or what is it I will present for you? It's about getting more transparency process. And especially also when you're doing more and more complex analysis, you have to ensure that it's the right values, the right parameters that you put into your model, especially when you're doing the safety models. And when you work with the FDS, for example, you have 650 different parameters to work with. So how to ensure that you have put in the right parameters for the right problem. Then you're going to need some kind of auditing process, if it's internal or external. It depends on the different countries' regulations. But like in Sweden, we always work with the internal quality control. Auditing is internal, but we could take the use of a third party. But then they also work as consultants. And when we have done this auditing in a good way, systematic way, then of course we hope that we could increase the errors. But I don't have to do another calculation because I forgot to put on a ventilation system, or I forgot to define my fire as alpha T2 square, or I put the starting point wrong. Because of all these different kind of parameters to work with, I have to ensure that they are right and do less errors, and increase the quality of the product. And if I could spare time on the analysis, on the pre-processing of the analyzing, then I could use more time to really analyze the result from my analysis. Like when I'm doing my safety analysis, I don't want to spend so much time building my model or define my fire in the model. I want to spend most of my time analyzing the result to see, do I really fulfill the pre-accepted solutions, or fulfill the requirements that I have to fulfill. So get more time for the most important part of this analysis, analyzing the results from the output from the different products that we use. And it will increase the quality for the customers, but also for ourselves as consultants. And we as a company, we changed focus about 2.5 years ago. Earlier we were talking about how some internal kind of guidance and know how to do things, but we never took the time or the resources to do so, because it costs some time to do it. But we did some errors, and we forgot to do some quality checks at our analysis, especially when we did safety analysis. And we had communicated wrong answers to our customers, and it was a quite big problem in the company that we didn't know exactly how to do things. And because of that, I, as a technical director, decided that we have to get these internal guidelines of in-depth technical focus. And in summer 2012, we started to develop 2 guidelines. One about smoke control, not only safety simulations, but smoke control. And one about evacuation, the concept of it, and how to use steps as a program. We use steps when we do our simulations. It's a program from Montreal in England. And when we do the smoke control calculations, we use FDS. So the guidance was taken and was produced because we had so much problem with analysis. And it was really good when we started working with it. We realized that we had some problems in terms that we have to solve, that we have to talk to find a way forward. But by doing this, we increased the knowledge of how we could define the problem and solve the problem as well. And after working with the guidance for about half a year internal, we realized it's good, it's going to work really good. So we decided to make 2 external copies. So it's free to take them, to use them, and we want to spread the word about it. And then it's the one about smoke control, how to do it, and it's the one about evacuation. But we also have 2 other guidelines, but that hopefully will go external late this summer in the autumn. And it's about how to work with load-bearing construction and fires. How to fulfill EQS. EQS is a Swedish part of geocode. How to work with that, how to understand the problem in a good way, and know what kind of solution to work with. And this one is going to be all external. And we also have this one about, in Sweden we have regulations about the ventilation systems and how to prevent that fire and smoke is spread within the ventilation system. And we are allowed to do calculations on this. Is it the same here in Iceland? Ventilation?
Ja, typ.
Almost.
Ja, det kommer igång. Det är liksom guidelines inte publicerat sen. Är typ klara. Så att vi bara snabbt. Och då har vi adopterat liksom med fire safety approach. Med beräkning med progress och liknande.
And yeah, and that's the kind of guidance we also have. How to use this program, how to understand the problem, and how to understand the result from the program, and how could we formulate this in a good way that the customer understands what we are talking about. So we don't use our language in a bad way, so we are always talking this alpha T2 square, but what does it really mean for that part? And we have this guidance as well for that one. But hopefully they will be external, and then you can find them at the homepage. But the concept of our guidelines, we have called them Brilliant's best practice. It's the company's best way of doing things. It's perhaps not the best practice in the world, but it was the best we had in Brilliant when we started with it. And it's 6 important parts in the guidelines. It's not, as I told you in the beginning, it's not only about how to build your model in like FD and S is done. It's more important things than that. And one of is the concept. What is this fire safety objective, and how should you work with this? And our processing, our guidance comes from SFP. You know SFP, Society of Fire Protection Engineers. They gave out a guidance about 4 or 5 years ago about the way of defining a problem, and we use that kind of process in our guidance to be in the line with the SFP. And we have a policy in the company to work as far as possible according to SFP's guidelines to ensure a good quality. And it's not only about the fire safety engineering part, it's also about the pre-accepted solution part and to do the fire concept. But we also realize that we have to describe the rules about this concept. Why do we have to do the analysis and connect it to the Swedish regulations? And 2012 we got new regulations in Sweden that had one part was about fire safety engineering, and we was given some guidance that you should do in this way when you do fire safety engineering. If you don't do it in this way, you have big problems to do it at all. It was what the authority told us. So the industry had to work with that, these models that the regulation, the authority was given to us. But it was difficult to understand. It was like magic numbers. We got this kind of fire that we should put in our models, that should have the heat of combustion on 20 megajoule kilo, and we should have this soot yield, and we should have this yield of coal monoxide. But it's not built on any scientific approach, so we couldn't just take the fire characteristics and put it in our model, but we had to describe it in a better way to understand why have they done this and how could we meet this problem and use this data. And that's the background and the regulations, just to increase the understanding of the things that we're going to work with. And then we described how can you do this kind of analysis to answer these kind of questions. Because in fire safety engineering in Sweden, it's have been a trend that you always should use the newest model, the best program at the market. But when you do it, then you always would work with, for example, safety when you do smoke control calculation. But depending on your problem, you can do it in another way. So we tried to present a more nuanced way of seeing a problem, to not do as we always have done, but try to think in other directions. So we described different methods to do it. You could use like hand calculations. You could use two-zone model sometimes, and you could also use this really complex safety modeling. But we said you can use this depending on the complexity of your problem. But if you choose this way, then you should use it in this direction. You use this kind of numbers to fulfill the regulations. And then we gave some hands-on, really hand-on guidelines on how to do things in the programs that we use. Like if we have FDS, and we gave guidance on how to define your fire, how to define your vents, and a lot of things that you should think of, like I will do it in, if you're going to build a wall, ensure that it's defined in this kind of way, use this string of code in the program. So it was very hands-on. The same concept when you're going to work with steps in your evacuation modeling. Use this kind of grid and this kind of definition of your walls and persons in the model to ensure that you have the right quality to fulfill the regulations. And then we describe our auditing system depending on to do it in sub-parts that before you start the calculation you have to have a quality check to ensure that the problem is right defined and you have chosen your right kind of program to use. And when you've done that quality check, you have a quality check that all the input parameters in your model is correct. It's in line with the guidance. And if it's in line with the guidance, it will be in line with the Swedish regulations. And when you've done your simulations, your calculations, you have a quality check that you ensure that the result is okay. It's no extreme values. The values are in the median, that is what you could think about, and you can do some benchmark about hand calculations to see in what level do we get this result. And then the last part of the quality check is, do I really answer the question that I found was the problem? Do I give an answer to the problem? Sometimes you just do your calculation, you get a number and you send it away, but you haven't answered the question that was the basis for the problem. So 4 different kind of quality checks. It's nothing hard, but you have to do them. You have to sit down with one that you're going to do the auditing, and they're going to ask questions about the problem and what input data you have used. And then, of course, we have to define how to document your analysis and how to do it in a good way. Especially, you have to separate from a good way in a scientific meaning and in a good way from the consultant's perspective. Because if I'm going to write a report from an academic perspective then it's going to be quite hard to read for the one who doesn't really understand the question. The architect or the project leader in the project that I'm working with. So we have to change the way we usually write reports to get it like a more interesting part of it. And the most important part is always in the beginning. But we shouldn't. But we have to ensure that we don't miss any important parts. So the one that reads the report will find the answer to the question first, and then when you're reading more and more, you will get more and more information about how you have done your problem. It's the other way around compared to how you usually do this academic report, that you start with your problem and then you work it down to the answer your question. We turn it around. But you have to know what parts do you always have to take in to give good quality and know that you have answered your question. I will show you how this would look like. Well, we can take And it's important to know it's not just about the program and how to use it, it's about the whole concept. And one part that I forgot to mention, we also give some kind of background information about the phenomenon to work with, like what is this fire dynamics, how to understand the concepts of it, because it's the guidelines also works good as introducing documents for junior consultants in the company, that they could read, understand the process of the company, but also that they could increase their knowledge about a certain aspect of fire safety. And so we work with this one, the aspects of it. And the different kind of ventilation systems to work with. Different kind of, if it's thermal or if it's mechanical, what's the difference and how to see the problem with the different systems. also some specific things that could happen when you work with different kind of systems, like plug holding. I don't know if you know about it, but it's when you're using mechanical fans to evacuate smoke, it could be a phenomenon, be some problem that you only evacuate the fresh air, not the fire gases. And one important thing that we also have to highlight is, if you're gonna use smoke evacuation, you're gonna take something out from the building, you have to put something into the building. The concept when we do this fire smoke simulation, we usually forget to ensure that we get the air into the building. And now how the relation should be, so you have this in mind when you start modeling. If it's a two-cell model or if it's a CFD model, you have to know, you always have to ensure inlet. Yes. And then we have this hand calculations. How to do it? In what way can you do it? Can we use the mathematics that, for example, Björn Karlsson presented in 5 dynamics? Yes, we can, in some certain situations. And we also work with this kind of more important things is always highlighted like this, so you don't forget to do it. And we also talked about this solar modeling. And after working about 7 years and doing a lot of CFD modeling, I think it should be good to go back to the two-source modeling, especially for me as a designer. Then I can do a lot of simulations quite quick to get a feeling of what is the real problem here, what can I do with it. And instead of doing only 4 simulations with CFD, I could do about 40 with our two-source model, and to understand the concept. And because I always work like it's the visibility that is the first parameter that get put up, then I can focus on that one. I got some first information, and if I feel that I don't have the whole picture to work with from a two-source modeling, then I can go to the CFD modeling. But not always go to the CFD model first. And it's also a part of when can I use it and when can I not use it. So I understand the limitations of different kind of models. And also in an easy way to see, okay, it's okay to work with it when you do the height of the smoke layer. But it's not so good to use when you're gonna analyze like radiation, then you should use another program. And we also give this practical guidance. When you're going to work in a project, you're going to work with a design. What should you think about? And then we have the CFD modeling as well. A bit information about the concept, the limitations, when you can use it and not use it, and what kind of algorithm is it that you work with? What is the most important parameters to ensure when you do this kind of analysis? And of course, verifying and verifying. How do you know that this model